It's a real privilege for me to be here in Excellence Center in Malaysia. Sorry, I'm so tall. And yeah, as Satyam indicated, I will deliver my talk in two parts. One is really research, and I left out the basics and really went for the applied. I will talk a little bit about some of the things that I think you're maybe less familiar with. And the second part is really focused more on students and how to present your thesis and how to defend research. First of all, I would like to know, you're all biologists or chemists, or like the background of the students? You're biologists or marine science, all of you? Okay. Okay. So anyways, that's good to know. So let's me start visually with a number of drawings. Because when you say people and mangroves, well, mangroves are occurring in 123 countries in the world, and in most of the countries the people are dependent on the mangrove. And so when you ask any school child to draw about mangroves or about mangrove conservation, these are the type of drawings that you get. So this is, try to use a mouse. This is a 14-year-old boy from Kenya who drew the mangrove with all the fishing techniques, with the wooden logs from the forest and so forth. I don't know why the airplane is there, but anyway, that doesn't matter. Whereas this Sri Lankan, also 14-year-old girl, she really drew how I would depict the mangrove myself, that the mangrove is carrying the fisheries. And that's really what it does. It's one of the most important functions of the mangroves. This drawing, on the other hand, is not from a child. It's from a fisherman with 18 years of experience in lagoon fisheries. And so if you look at the detail of that Rhizophora apiculata tree, it's amazing how correct. So it means also that the people that are using and are living and foraging in this forest, they also look very carefully to the signs of the tree, what is the tree telling them, what is the health status of the ecosystem. They all know there's a lot of local ecological knowledge with these people. And that brings me to the main basis, the main concept of this talk. It's about socio-ecology and ethnobiology. Sometimes I use ethnobiology, sometimes I use the term socio-ecology. So ethnobiology is the study of the reciprocal interaction between the people and their natural environment. And you can actually split it or split the main concepts into the indigenous part, which is more towards the people. And we talk about indigenous people. Their traditional lifestyles. If you use traditional, it's more about the lifestyles and all the local uses of the mangrove. And so in our research team, for example, we have been working for more than 20 years now on applying a very structured socio-economic questionnaire in many countries in the world. So we have been doing this in Brazil, Cameroon, Gambia, Kenya, Sri Lanka, Vietnam. So a lot of different countries, always the same questionnaire to try and understand globally how people see and use the mangrove. And so when you're talking about ethnobiology, well, in some countries it is economic botany or ethnobotany. In other countries it's more ethnozoology. It's more the use of traditional use of animals. Well, in the ethno-sciences you have a lot of different subfields. You can even talk about ethnochemistry, ethnoclimatology, ethnomathematics. There are a lot of different ethno fields, but since I'm a biologist, I will stick to ethnobiology. And so in ethnobiology, what is very important is the people's world view, how they view the world, and which kind of discourses that they use. So discourse analysis is another research window in which I'm involved, and my postdoc Jean Huget is involved in that as well. And it is more about how, it really means what it means in English, yeah? A discourse, a way of speaking about a certain topic. So if I tell you biological conservation, well, the politician will say it's less important than economic development, because that's the politician's discourse, that's what's important for him. Well, maybe the Ministry of Economy is important for him. If you look at the biologist, the researcher, they will say, no, it's very important because loss of species and so forth. So every person, every background, every profession has their own discourse. And what we try to do in our research, for example, is try to identify by interviewing many people who has which type of discourse, and how can we then mix these discourses in relation to policy. Because eventually, when you want to protect an environment, or when you want to manage an environment, it is going through the politicians, it is going through people. There is no such thing as nature management. There is no such thing as water management. There is no such thing as coastal zone management. It's people management. The coastal zone, the water, the nature, it knows how to take care of itself. But it's the people that you have to manage. So if you want to manage with the people, you have to understand how they view the world. And for example, I've given here an example, a non-mangrove example about hail in the Andes in South America. If you look at science and you ask what is hail, well, they will explain how rain falls and freezes and so forth, and then it forms ice balls and they fall down. So it's more about the how that is important. And when you look at the Andean view, for example, you can read here the explanation that the South American Indian populations give, saying that Mother Earth produces as a function of how humans treat her. If we treat her well, there will be good harvests and protection for everyone. If we treat her badly, natural disasters will occur and the harvest will suffer or may even disappear. So they're more into the why things happen, and still about hail, if you would read the whole table. But it's more about all these questions about why the hail falls out of the sky. And it's important to try and merge the scientific knowledge and the traditional forms of knowledge in order to really get to the people. And I will give several case studies about that. Now, when we talk about traditions and about cultural values, it's also about language, because in many countries there is a lot of local languages and a lot of local ecological knowledge that is transferred from one generation to another in their own language. But there is many languages which are at risk. So here you see, I think, a top 10 of different countries. I'm sorry, Satyam, but India is apparently #1. No, but you have to really look at the colors. It's not so much about the length of the bar, because that just shows how many languages there are. What is important is how many languages are endangered, which is the blue part, or highly endangered, which is the lighter blue part, and then extinct. And you see, for example, and that's not a surprise, I think, in the United States, a lot of languages are either extinct or highly endangered, because there is so much loss of the North American Indian populations and their local practices. So with this modernization of the world, you also lose languages, you lose local ecological knowledge and this link with the environment, unfortunately. So people and their worldview and their discourses, they're also linked to the cultural identity, the cultural heritage. When I already talked about traditional, I spoke about local ecological knowledge. You often find also the abbreviations TEK, which is traditional ecological knowledge, or IKS, which is indigenous knowledge systems. And so I plead for actually in this integration, as I said before, of scientific and traditional forms of knowledge. And what's important then is to define what do we mean by nature and what do we mean by people. And there was a paper in Science a couple of years ago that showed very well how actually in the entire world the discourses changed from one, maybe not to another, but in parallel to other ways of viewing nature and people. Originally, when you look about the concepts of nature and people from the 1970s till, or from 1900 in the 1970s, it's nature for itself. It was viewed as, well, you have the species, you have wilderness, you have protected areas, and you have then people who are studying it with ecology and with habitat ecology and so forth. And then from 1900 to from 1980 to 1990, I'm reading it upside down, it's more about nature despite the effect that people can harm nature, nature despite people. Then from 2000 to 2005, it's also viewed as nature for the people. So there was more seen as, yeah, nature is there at the good of the people. People can use nature basically. And then eventually now, and this evolves, maybe now we are already a few years later, maybe there's another one, but now people also look at people and nature. Both of them can actually look next to the other, and if you look at the key ideas, it's more about change, about resilience, about adaptability. And these are really very important terms, because very often when we manage the people, we manage for a single resource. When we do forestry, we manage to optimize the yield of the forests, to optimize the wood production. But more and more, we have to go towards not sustaining a certain production, but actually sustaining flexibility, sustaining the ability of the system to change with climate, to change with human pressure. So we have to actually manage environments much more so that they can change. That's really very important towards the future. And this word resilience is very important. It's the possibility for a system to return back to its original functional features after a perturbation. So this is all part of what we now call social ecological systems. And social ecological systems, I will not discuss everything in detail here, but as the term says it, it has a social component and it has an ecological component. And each of these social and ecological components are actually managed by what we call slow variables and fast variables. These fast variables, they are things that change very quickly. It can be the population density, it can change from one year to another, can be the fire event, for example, if you talk about the forests, that is tsunami, things that can really change very quickly. And then you have the things that are more slow in changing, like here you see the fire event, the fire regime, the disturbance regime, that's something different. That is, after how many years do you get another fire in the ecosystem? Or after how many years do you get another inundation in a system? That is not changing very quickly. In fact, it takes years and decades to build up a certain disturbance regime. So those are slow variables. And then you have what they call also critical slow variables. Those are variables that are taking really very, very long to build up, but they're very quickly eroded. If you look at the ecological part, it's, for example, soil. Making soil, producing soil is taking a lot of time, but eroding it, just one rain shower is enough to erode it. And the social component, I don't know, let's try if you can come up with a critical slow variable and the social component. What would take very long to build up and is lost very easily? You have to speak up if you There's something that takes very long to build up, but it's very easily eroded, it's very easily lost. I would say think about interpersonal relationships. Belief?
In the governing system.
Yes, but you can be a fast believer also. if I convince you, you can also be believer in a very short term. We are getting very close, yeah, relationships. Something which really takes very long, and then something happens and it's just lost. Just like
Custom?
that.
Custom?
Customs? No, let's think about the relationships. You said courage? Marriage. Well, let's close down the discussion there. I will give you the answer. It's trust. Of course, it's related to relation and to, because it takes very long to build up trust. You really have to know somebody very well, and but then even if you know each other for 30 years and maybe something happens, you are crossed by somebody, you can lose all the trust. It's all gone, and you can start building up again. But that's typical critical slow variable in the social component. And these social ecological systems, they're full of this kind of relationships on fast changing stuff, slow changing stuff, and then they are from the outside, from externally, they're influenced by everything which is global. It's global politics, it's global climate change, and so forth. So it's quite a complex system, but you can actually transpose it to many different systems. Now, we talked about belief very often, and now we're going towards the mangrove slowly. Belief is part of a person's worldview, yeah, of course. And I always like to show Sri Lanka as a nice example, because you have on a very small island, you have Christians, you have Muslims, you have Buddhists, you have Hindus, and they all live quite in peace, by the way. All live together, but of course they all have different ways of viewing the nature and viewing the world. And there is a very interesting book which is called Faith in Conservation, and it actually displays all the big religions of the world, and how people, and especially biological conservation initiatives, were able to succeed in conserving a certain ecosystem by going back to the holy scriptures of the people's beliefs in that particular country. So it has, so the ARC is the Alliance of Religions and Conservation. Oops, here, ARC. And it's a very small book, actually. It's maybe 100 pages, and it has from all these different religious examples. And I will be touching upon two examples today: Hinduism and Islam. So if you look at, well, and the Hinduism part is only linked marginally to the religion, but as you probably know, in India, the holy cow is holy. People, they don't touch the holy cow, they don't eat, they don't disturb. Instead, they have the feral water buffaloes, the half-wild water buffaloes that they use for labor in the field, for milking, for meat, for everything. And now we are in Andhra Pradesh, in India, where you have had this ethnozoological relationship with herdsmen and these half-wild water buffaloes for thousands of years. And then suddenly the forest department claims that, well, yeah, these feral water buffaloes, they are a problem for the regeneration of mangroves. And so they made laws and everything to keep the buffaloes out of the mangrove. It can be very harsh. It goes not only to fining, but even slaughtering the buffaloes in case the herdsmen are found repeatedly with their cattle in the forest, which is of course leading to economic hardships. But then we as a scientist, so we are all scientists, we don't say forest department is right or forest department is wrong. No, we go and do science and we check what is known and what is not known. So that's what we did. So we went to ask a number of questions. How have people used the buffaloes in the mangrove? How did they perceive the changes? How has the banning of the water buffalo affected these people? How do the feral water buffaloes affect the mangrove? And so forth. And so the first question, of course, that we have to answer, first of all, does the feral water buffalo consume mangroves, yes or no? Well, that's quite easy, yes, or they are in the field eating leaves, browsing leaves actually, or the herdsmen cut branches, bring it back to back to home, and the calves and the mother feral water buffaloes are consuming the leaves, as you can see here at home. But then, is it a problem for the mangrove? And that's more of a challenge, because you have to experimentally try and find a way of monitoring the damage that these feral water buffaloes do on the leaves, on the browsing. And it is a very big area. It's the Godavari Delta in India, one of the big rivers. So the mangrove area is not small at all. And it actually took us many different days in order to get back to the same place. So we couldn't just count number of leaves. That could be easy. You count number of leaves, you come back so many days later. But in the meantime, maybe you have new leaves that you cannot monitor. So what we did is actually focus on the height of the branch tip and the branch length from a certain marker, but not on the number of or the length of the leaves. And so let's go immediately to our results. We saw that the branch length, so I forgot to say that we did our experiments in an area free of water buffaloes and in an area with water buffaloes. And so when we compare, we saw that these trees, they grow in both sides. So the branch length increases in both sides. So it means that in both sides there is growth of this, so that means that the damaged, the impacted side is not necessarily worse off than the non-impacted side. We also, let me jump to the last one, because it's going to take too long otherwise. And that was the most important conclusion, is number 4. We actually saw that the grazing, not the grazing, the browsing of the mangrove leaves induced compensatory regrowth. Now in plant science, compensatory regrowth is typically known in grassy vegetation, herbaceous vegetation. It means that if a big grazer is eating the grass is growing better, not worse, better. So actually that's what we found now in Avicennia. So the fact that the water buffaloes, they browse the mangroves, makes these leaves grow better. So whereas the forest department said there is a problem with the cattle and the grazing of the mangroves, we found the opposite. Now it's not that easy to conclude also, because well, we don't know the carrying capacity, we don't know how many water buffaloes we have, and we also don't know other effects of the water buffaloes, like maybe they're trampling the seeds, and it is the seeds that don't grow, but at least what we can say as scientists is that for the adult trees, there is no problem with browsing the mangrove leaves, because they grow actually better, and the water buffalo is doing a favor to the mangrove. We went further and also started, now you see again the socio-ecological aspect of our research team, interview the people in 2 different zones, because one zone was protected. It's called the Koringa Wildlife Sanctuary, and the other one was unprotected. And with this protection status, you had different types of, different characteristics. There was more control in the protected side as opposed to the non-protected side. There was less new aquaculture farms. There was also what was prohibited was different. For example, in a non-protected zone, there was no felling of trees or collection of green wood, but you could collect dead wood, for example. Whereas in the protected side, you could not collect anything. And so if I jump also to the results, and now we're trying to put it in a policy framework, you have, as I said, your politician is coming up with his management. And it's, in this case, for the forest department, it's forest management policy. We, as scientists, first of all, and that's a window I'm not going to talk about today, but our basis for almost everything we do is remote sensing. So we start with available aerial photographs, available satellite images to see how there's landscape changes. So we see, with remote sensing, we see a lot of changes in quantity, now more and more in quality also. And so when there is this management from the politician in the forest department, they come up with with management rules, like we're going to replant mangroves, we're going to ban cutting, and we're going to ban grazing mangroves. Now, from our ethnobiological surveys, we can also ask much more details about the quality. Now, remote sensing becomes really very interesting also to see the quality of different trees. But also the people, they have seen the quality of the ecosystem change for the past 30 years. So even though remote sensing gives you the actual status, you still have a lot of information about the people because they have witnessed all these changes. So they can tell you more about that. Now, one of the things that was quite comforting in our interviews was that the people that were living in this protected zone, they saw that there was much less decrease in that protected zone as opposed to the non-protected zone, or vice versa. The non-protected zone, there's much more decrease in mangrove quality. Now, it is good for the cutting ban. It means that a ban on mangrove cutting is kind of positive in a way, but then you have to see that there is not a fellow politician that is trying to clear the mangrove for land. Because that's now typical what we found. Now, this is our results from India and Sri Lanka together. We saw that through political patronage, the politicians were able to clear land that was supposed to be conserved. Whereas the fellow minister was saying, yeah, but we have to cut. So these kind of conflicts, that's politics. Now I'm not going to go there. I'm staying within the forest department, because in the forest department what's important here is that whatever management or rule or law is imposed, there are some alternatives to it. And these alternatives, they were given by the forest department without investigating too much. For example, the alternative to collecting fuel wood and firewood was to collect other terrestrial wood or to use gas stoves. So they were distributing gas stoves instead. Yes, but the people say that mangroves, they produce much less smoke, and they're much more calorific when burning. And mangrove wood is nearby. I don't have to walk 17 kilometers to get my terrestrial wood. So the alternatives is not a bad thing, but it's not at the heart of the reality of the people. Second example, as an alternative for fencing and wood construction, they were also, again, proposing terrestrial wood. But then again, people say, yes, but mangrove wood is more insect resistant. Mangrove wood is more water resistant. Mangrove wood is more durable. In Kenya, we have forts that have been built 300 years ago or more with mangrove wood, and they're still standing in a touristic place. And the third one is then precisely this feral water buffalo issue. As an alternative to using feral water buffaloes, they were proposing hybrid cows. Now, don't ask me the details about the hybrid cows. I don't know, they're not bionic animals or something. But there are some type of cow which is not the holy cow and not the feral water buffalo. Till today, I still didn't see a picture of, of such a cow, but okay. And so people are saying, yes, but the feral water buffalo needs much less care. They give much more milk. They are more resistant against diseases. They are less expensive. They eat my mangrove fodder, which is just next door. Whereas the hybrid cow, it needs a whole lot more care, and they're not as productive. So all this shows actually that, I'm going to skip this because this I already said it, shows actually that through these botanical, zoological interviews on mangroves and feral water buffaloes, you can view the advantages and the disadvantages of all these different alternatives. And through remote sensing and conservation, you can propose alternatives, but eventually these alternatives and this entire policy should be at the heart of the economic reality of the people, the ecological reality, which is basically the nature, and the socio-cultural reality of the people. Because if that is not happening, if you tell someone, stop cutting mangrove wood for cooking, it's like saying, stop breathing, because they're going to the mangrove every day. Now, what is more of an ethical problem is that you have this huge population explosion. What was feasible 5,000 years ago in India is maybe not feasible anymore today because there's many more people than what the ecosystem can carry. That's an ethical problem. So, but it's just to show it's not simple to solve. And at least our part, our scientific biological part, or ethnobiological part is the one that I just showed. Second case study is about fisheries management and Islam. And the case study is in the Tanzanian coast. So you have Zanzibar, which is an island, Pemba and Unguja Islands in Zanzibar, are very long traditional communities are living there. They have links to Oman, Yemen, through the Arabic trade routes. So you have generation after generation, you have these fishermen that have been living there for centuries and that know exactly when to put their nets, at what time, how long to leave their nets, and when to go and collect the fish. But then someone introduced dynamite fishing. It's very easy. You light the dynamite, you throw it, boom, and the fish, they come and float. You take your net, you take the fish, you go home. Yes, except that they didn't tell the people that the dynamite kills the plankton, kills the coral reef, kills everything which is related to the mangrove and to the fish in the first place. And then we try to solve this problem. And then you have a whole system. The government comes, they fail. The NGO comes with education programs, they fail. They put laws to ban dynamite fishing and fines. People don't care. They sent the scientists. The scientist was going to solve everything. Scientists came back, they failed, they couldn't do anything. So then eventually, there was a joint venture between the NGOs CARE International, the Worldwide Fund for Nature, the Alliance of Religion and Conservation I referred to before, and the Islamic Foundation for Ecology and Environmental Science. And so they went back to the Holy Quran. And if you look at Surah 731, you will read that, O children of Adam, look to your adornment at every place of worship and eat and drink. But waste not by excess, for Allah loved not the wasters. It's a citation from Quran. And if you add to that the stories about the Prophet Muhammad ﷺ, you will see that there are lots of different sayings, hadith, you know them, that teach people on how to use the environment. To give an example, I will come to the example here, but to give an example, if you have a river and you have to take wudu, you don't go and stand in the river and take wudu. No, you take a recipient, you take a bucket, you bring it next to the river and you take wudu in the bucket. That's how you don't waste whatever resource is there. Similarly, sorry. These sayings, they were interpreted also as if you have a fish this size that can grow to this size, then don't harvest it when it is this size. Right? Fish that is the size of. So, by the dynamite fishing, they were killing, as I said, all the plankton, but they are also killing all the juvenile fish this size. And so by explaining this to the people through hadith, through Quran, that was the only way that actually this whole venture was able to ban dynamite fishing. So there also, the politicians cannot all solve it either. It's not the scientists alone cannot solve it either. It's a joint venture of different scientists with different backgrounds, ecology, political sciences, economical science, and so forth, that have to join to solve such a problem. It's also what is studied by the field of human ecology. I don't know if you've heard about human ecology. Well, that's a holistic science field that is actually able to deal with this kind of problems. Now, more to mangroves. You probably know more than anyone else that there's a lot of different uses of mangroves. I'm going to give you a few worldwide examples now. So this is a number of pictures from living in mangroves. The first picture on the slide and this one here in black and white, they are pictures taken by Norman Duke from Australia. And they show Aboriginal people fishing in New South Wales in Australia. And they're making actually a shield out of the bark of Avicennia. This is a photo from Sri Lanka. Of course, people there go and wash in the mangrove, but they also keep the mangroves quite intact. If you see their houses here and there, the pathways to their houses are cut, but then the rest of the forest is like stayed. And for the rest, they have everything. There's even electricity in the air. They keep living really in or next to the forest. This lady, this is amazing. If I tell you what she's wearing, you won't believe it. Huh? And her entire dress is made of crab legs. So in Brazil, it's Brazilian, North Brazil, I have to say, because Brazil is very big. North of Brazil, they have very traditional communities, and one of the major socio-ecological relationships with the mangrove is through the crab fisheries. Ucides cordatus is the main crab species which is living there. They have very tight, and she has actually, and it's not very clear, but she has actually a crab in her hand. See here? Well, her entire dress, everything she's wearing is made of crab legs, so made together. And there's an annual contest. I don't know if it's the prettiest girl or the prettiest dresser, I don't know. But it's about showing this ethnozoological relationship with crabs. So, worldwide examples in plants now. Rhizophora used for charcoal, firewood, house building. You know that. Cereops, poles, fishing spears, fencing, Avicennia, canoes, furniture, firewood. Indirectly, honeybees. Beekeeping is very important. Nipa fruticans, like any palm. Nipa is a very important tree because every part is used of it. In a coconut, it's even a better example because the people use the wood, people use the leaves, people use the husks from the coconut with pillows, mattresses, oil, soap, milk, you name it. You know the coconut. You can actually, if you want more information about, in general, ethnobiology of mangroves, look at this paper. It's a review from 2008. We are almost 10 years later, but it's still the most recent review of things, and it's still quite accurate. Other worldwide examples: edible fruit and other food items, medicinal, chemical uses. I'm just giving a few examples here for different aches and pains and skin disorders and so forth. Fisheries, of course, with this very unique brush pile fishing in Sri Lanka, where they actually use tree stems and cut roots and leaves from palms to mimic a root complex. The fish are then migrating to that false root complex as they would in a true root complex. And then after some time, when the fish are big, the fishermen just put a net around this brush pile and just harvest the fish. And it's so interesting, and for remote sensing, Professor Heidi, is so interesting because these brush piles, they are made year after year after year at the same place. So what we ended up doing is using these things as ground control points to georeference our images. Fuel wood, well, doesn't need any explanation. This is Sri Lanka, this is Kenya. Leisure tourism, although I really wonder whether they read the sign. It's in Australia. And when I was asking the person who took this photo, he said, do people read the signs? I mean, crocodile attacks and the children are just playing in the water? Yeah, but they put these signs everywhere. Yeah, probably because there's crocodiles everywhere in Australia. Anyway, back to the research. Now time to mix actually our questionnaires with our ecology. And so in our ecology we have remote sensing, you have measurements of a whole list of variables and parameters in the field. We have our interviews. And then we have in our basic questionnaire that we've been using for 20 years now in these different countries, how do you use mangrove products, where, how much, how often, what are the changes that you have seen over time, the witness accounts. And these are some results. So what you can see from this table is that there is a lot of uses that are universal. You find it in every country, and I think fuel wood and construction wood is the top two, basically. You find it in every country. But then also there is, well, in almost every country, there is something that you only find in that country. So for example, in the New World mangroves, which are Mexico, but also Gambia, it's the same biogeographical region, although it's Africa, it's the same few species, Laguncularia, Avicennia. They make tea out of these species. In Kenya, they use certain species to make an insecticide against mosquitoes. In Sri Lanka, you have the brush pile, as I just showed you, and in Vietnam, they chop up Avicennia leaves together with cow dung to make an improved fertilizer. So that was quite unique. Food and drink. In Sri Lanka, they have made from Soneracia cazuelaris, which has the mangrove apple as a vernacular name, mangrove apple juice. They even make this peck-rooted mangrove jam or Soneracia ice cream. And believe me, well, you see the bottles there, and it's nice. It really tastes very nice. And I asked Satyam yesterday if there's any commercial uses in Malaysia. There are, but you don't have this drink. Okay. But this is actually a drink. It is desserts, ice cream you have. For Nipa ice cream. I really want a Nipa ice cream before I go home then. You have to find a Nipa ice cream for me. Okay, so this bottling that you see there, it was made by a small NGO, which is called the Small Fishers Federation of Lanka, which is an NGO working around fisher folk families, looking after children that dropped out of school, looking after widows of fishermen, and so forth. So they made it by the people, for the people, actually. Now let's look a bit more in detail. So we're zooming now on Mexico, Kenya, and Vietnam. And especially, well, let's forget about this. Let's look at the main species that are used for the main purpose. So the main purpose in Mexico is fuel wood, in Kenya building wood, in Vietnam fertilizer. But you see, it's not just one species that is used. It's several species that are used. And if you look only for Kenya, for example, and you look in Media Creek 98, the percentage, the proportions with which each of these 6 species are used is different also. You see, especially Bruguiera gymnorrhiza, Cerus tagal, and Rhizophora mucronata, which is used very much. And why is that? Because actually each of these species has their own place in the construction of a house. So Rhizophora is used for walls, corner pillars. Bruguiera is used for rooftops and ceilings. Seriops is used for this interweaving network that you see here. And then depending on the wealth of the people, these skeletons, house skeletons are filled with mud or with cement or with a mixture between cement and coral stones. And then the whole thing is very often, also depending on the wealth, cemented from the outside. So although from the outside you may see a cemented house, the inside may be just mangrove wood and mud. And you see that the changes, so this local ecological knowledge that is lost, you see it here. People are, as they grow more wealthy, they want to rebuild their house, but they don't want to break down the old house before the new house is there. So they start building their new house around their old house, and eventually they will break down the old house inside. So it's a bit complex, but anyway, it seems to work. So if you combine this now with the ecological knowledge, you have all the ecological things that you see in the field, and you have the information that you get from the people. For example, if you look at the harvesting intensity, allowed 6 scores per month. 1 score is 20 poles. And in Kenya, these poles, they are per size classes. So you have small poles, thicker poles, very thick poles. But in practice, they harvest 48 scores per month. So there is this conflict between what is allowed and what is practiced. And let me go a little bit faster. Sorry, I'm going to move on a little bit. I'm going to go to this one. Because what the people harvest is obviously what they prefer, but what they harvest is not necessarily what is going to regenerate. So we're not talking about areas with planting initiatives, we're talking about areas with natural regrowth. And you can actually, by comparing, that's now on ecological field data, by comparing the proportions of adult trees between species and the proportion of young trees, this is regeneration class 3 trees, between the same 2 species, you can actually, I'm not going to go into details of the numbers, but the main message of this table is that you can actually see a shift in dominance. Whereas in the adult tree layer, you don't see the shift in dominance yet. In the young tree layer, you see that for at least one of the two areas, there is already a shift from one species towards another species. And it's exactly what you see in the field also. This canopy gap here, the regeneration in that canopy gap is a species totally different from what was harvested. And so the links with management now is, of course, that as you see these changes in the forest, and as the forest department becomes more and more strict in their policy, with more controls and more expensive permits, and sometimes total ban of cutting, you get more illegal harvesting, and you get these vicious circles, because if you get more illegal harvesting, again you get too many cutters. So it's like a vicious circle. And so what are the alternatives to this current exploitation that is as important to investigate as well? So that's again socio-ecological research, because if you want to quit the cutting of mangroves for building wood, you have to have some alternatives. And our colleagues from the University of Florence, they actually investigated these 8 alternatives: casuarina, productive casuarina, coconut, productive coconut, dairy cow, ecotourism, improved fishing gear and food crops, as an alternative to building wood. And for each of these alternatives, they checked what was the environmental impact, annual income, the income fluctuations with market prices, with yields, and so forth and so forth. And it shows, for example, that in the 2 areas that we investigated, this is now in theory, the first choice was to have productive coconut, but there was not enough coconut for everyone. The second preferred thing was to stick with the building wood. And the third preferred thing was to have food crops, and that was actually what was feasible. And in the other area, it is actually the dairy cow that was the most. In the 2 cases, by coincidence, it's only the third choice that became the most feasible choice. But this shows you how you can actually look into alternatives to mangrove cutting, because if you don't have an alternative, you are back in the same situation as in the Indian case study. You have alternatives which are not at the heart of the reality of the people. Then we come to a country you've probably never heard of, but it's a very beautiful country in Asia. I'm here for the first time, so everything is impressive to me. So we're going to the west coast, Matang. This is the oldest mangrove forest that is managed in the world since 1902. And actually, there, you probably know, you have these cutting cycles of 30 years with 2 years of natural regeneration. Then you have 10, 15 years of growing, 1 thinning event, again 5 years of growing, second thinning event, and again 10 years of growing for clear cutting after 30 years, then the entire area. And this is a study we did a couple of years ago, investigating how much biomass is extracted at each step, at each thinning step and at each cutting step. And what we did especially is, I'm going to skip this, we tried to look at the stakeholder analysis. Who are the people that are involved in this cutting business? And this Matang is typically what I refer to as single resource management. So this forest only exists for the production of charcoal. That's the only reason it exists. And so there is different people that are involved. You have wood cutters, you have boat drivers, you have log bearers, log arrangers, fire monitors that are putting the fire in the kiln and managing the kilns, and so forth, up to the exporters. We are actually still in the process of publishing this, and everything is supervised by a supervisor. So, but it means that just for this charcoal business, you have so many different jobs that are there and that have to be done. It was a master's thesis that was awarded, by the way, with the Millennium Development Goals Award, and that looked at this whole procedure from the cutting in the forest over the boat driving, log arrangers, all these jobs that I've talked about, and then up to the packaging and the export towards Malaysia for domestic and Japan for foreign consumption. Now, for each step in that chain, we investigated how much the people earn, how much they spend, how much they are paid for the wood, and so forth. And what was quite interesting is to see that at that time there was a certain minimum wage for the country, I think that was. for earning money. There was only one job, it's mainly the tree cutters, that could survive by doing that job alone. All the other jobs, the people earned less than this minimum, sorry, my mouse is not working, than this minimum of 205 per month. This was this in ringgits, Malaysian ringgits. So it means that all these other jobs, these people had to combine jobs in order to get the minimum wage. Is it in euro? Okay. I thought it was already a little bit little. No. Oh yeah, it's written there. That's one euro is four Malaysian approximately.
Back timing. 14 is better.
214 is better. So we have to go back. So yeah, this was the last case. I have about 10 minutes left, so I'm going to speed up a little bit, because this shows that, okay, in terms of money, mangroves are worth quite a lot. Huh? If you look at these mangrove and tidal marshes in general, it's worth about 10,000 euro per hectare, so it's quite a lot. So worldwide, you cannot even read this number, it's 1,600 billion euros annually. Not bad. So what are the threats? Tourism, well, it's not only to mangrove, but also to coral reefs. Tourism, land conversion, land reclamation, overexploitation of the mangrove because of the calorific features, pollution inland, and erosion. Of course, it also affects the seagrass and the coral reef. Pollution, air pollution. This is a cement factory near a mangrove. And so forth. Mangrove is regarded as wastelands instead of wetlands. And I think if you look at this, I think you can assemble an entire car based on the garbage that is in this mangrove. Sorry, I'm gonna skip this one. Yeah. Also, of course, I'm just touching upon this because it's linked to tropical rainforest and terrestrial forest, because if land management is not well there, well, there is only one place for all the eroded sediments to go, and it's towards the mangrove, the seagrass, or the coral reef. Right? And if you look at the forest and the habitat that is lost in many different countries, well, it's quite amazing. And Malaysia is also there. Well, it's one of the better countries with 36% lost. But look at Bangladesh, 92%. Look at the Philippines, where is it? 94% of the habitats and of the mangroves. For the mangrove, it's 97, I believe, lost. So, I have to make a choice now. I'm going to skip this one. Sorry about that. Oh yeah, this is one that I will come back to that, how to display data badly. We'll come back to that later. I wanted to go to this case study, which is I think one of the last things that I will say, but it's a very long case study. So in Sri Lanka, water management has been done for many millennia in quite sustainable ways. But then in the 1960s, the ambition of water management changed drastically. And in our case study, we have a situation with 3 small rivers and 1 big river. And each of these rivers, especially the 3 smaller ones, they are feeding a coastal lagoon: Rekawa Lagoon, Kahanamodu Lagoon, and Kalametia Lagoon. And this is called the Walawi Ganga. Ganga means river in Sinhala. So it is the Walawi River, which was at a certain moment dammed to make a reservoir to divert these to all these little black lines, which are irrigation canals for rice fields and banana fields. And then the excess water was dumped into the basins of these 3 small rivers. Now all these river basins, they're not connected, so they're separate basins. So in the end, what happened was that you have an increased nutrient inflow and sedimentation, siltation of the lagoon mouths, and you had a whole lot of processes that converted these seawater lagoons into freshwater bodies. And I will show you how we got that. So again, we had our satellite imagery over different years. And in this case, this is a vegetation map based on the satellite images. and every color represents a mangrove species. And what you see, if you compare the three lagoons in 1956 and 1994, is it's not very visible in the first lagoon, but it's very visible in the second and the third one, is that in 94 you have much more color than in 56. So you have much more mangrove in general than in 56. Now, you could ask yourself, because local anthropogenic pressure has decreased, well, that was not the case. It had actually increased. Because maybe there was reforestation, that was also not the case. Because maybe there is a natural dynamism, that sometimes you have a lot of mangroves, sometimes you have few mangroves. We actually found that there is quite some dynamism. The case study that I just dropped now, I had to skip, was a case study about dynamism in mangroves. And yes, mangroves can be very dynamic. In 10 years' time, you can see major structural shifts over time. But the kind of changes that we saw in the satellite images were way bigger than we have ever seen before. Does it mean it can't happen? No, it's not because you didn't observe something before that it cannot happen. But if you model then how long it would take to have that type of canopy turnover, well, the modelers have done it, and they predicted a few hundred years of time to get an explosion of the mangroves to that magnitude. So what we did is we went back a few hundred of years in time to check whether the Sri Lankan coast has been dynamic or not. So we went archiving in the National Archives of the British East India Company, the Dutch East India Company. I went to France, I went to Denmark, I went to London, British Library, really doing, I felt like a historian. I really know now how a historian feels. So really dig through maps and books and logs and whatever to try and find things. We stuck with the maps because they were quite interesting, because the Dutch, they were genius map makers. And this is a map from 1753. It's almost 300 years old. But the kind of detail that is there is amazing. Okay, the shape of Sri Lanka is not the shape we know it is today. But we see, for example, location of rivers. We see in old Dutch freshwater, salt pans, sandbanks here. So all of these are elements that we as biologists today, we can use them to interpret how dynamic the coast was. Because that's what we try to understand. And eventually, by tracing these rivers, there's no such thing as georeferencing here, and we didn't even try. But we tried to do our best in tracking the same rivers on different archives. So you see, we found the different archives with the rivers indicated, and we could conclude from that that in dynamism of the rivers, we have never seen a natural dynamism to the extent of what was shown by this artificial human scale that we saw in the 1960s. Now, is that mangrove expansion good? Because you may think that mangrove scientists is complaining that we have more mangroves now. Why? Well, is that mangrove expansion good or is it not good? And for that we have to look a little bit more in detail, because it's not enough to look at whether the mangrove has increased or not. We have to see which mangroves have increased and which mangrove have decreased. And we have to subdivide vulnerable mangrove, resistant mangroves, and mangrove associates. And if you do that, you actually see that the mangrove expansion is actually not a good thing in this case, because the mangroves that are expanding are either the species that have very wide tolerances, like Avicennia. Avicennia, it can grow from very salty to fresh water. So, is that a problem? No, from fresh water may be exaggerated, but let's say seawater salinity to hyperhaline salinity of 120 promille. So 120 promille is 3 times saltier than seawater, right? So it's enormous. They don't grow higher than 1.5 meter approximately, but they're still growing. So Avicennia is not a good example. Excolcaria, not a good example, because it's one of the most disturbance-resistant mangroves. Acrostichum aureum, Aegisalas corniculatum, so and so. The mixed mangroves, which are the rhizophoras, the true mangroves, Rhizophora, Bruguiera, Cereops, Scandelia, those kind of species, they were actually increasing much less So actually what we see, in this case also, Acrostium is a mangrove associate. It's not even a mangrove. I wouldn't even dare to call it a mangrove because it's considered a pest. It's the first thing they try to remove to restore mangroves. If you look at Sonoracea caseolaris, is it a mangrove? Well, it's called the freshwater mangrove. And so no wonder that if your lagoon becomes fresh, that this species is going to explode. Is that a good sign of mangrove development? No. The true mangroves, the Rhizophora and so forth, they are in the mixed sections, and now you can start doing the statistics. Plus 200% for the disturbance resistant, plus 4% for the true mangroves, plus 60% for the associates, plus 6% for the mixed mangroves, plus 3,000% for the freshwater mangrove, minus 12% for the true mangroves. So what we see here is what we termed cryptic ecological degradation. So it's a degradation, ecological qualitative degradation that is cryptic. Cryptic means hidden. It is cryptic because it is masked by the fact that other species which are less important are gaining a lot of surface. And if you are a forest department, and the forest department in Sri Lanka is working like that you just look at mangrove as a whole, say, oh, mangrove, oh, more mangrove, oh, even more mangrove, oh, mangrove is doing very well. No, if you go and look in detail, mangrove is not doing well at all. So that's why it is so important to look at the qualitative changes in the field. And if you look at all the evidence we had hydrological evidence. I'm not going into the details. We had questionnaire survey data, which was also pointing in the same direction. For example, to give just one example here, the first part. Before the changes, the people were saying we did not use lagoon water for drinking, bathing, or washing. And after that dam building, they were saying lagoon water is used for bathing and washing. Now bathing, I leave it in the middle, but washing, that's very important. If you know something about washing, as a biologist, you wonder, what is he talking about? Well, I don't know if you ever tried to wash your clothes with salt water. If you don't know what I mean, just do it once and then wear the clothes the next day and you will understand perfectly what I'm talking about. Because if you wash your clothes with water from the lagoon, from a sea lagoon, it means it's fresh. It means it's fresh water, it's not salty at all. And this is now ecological proof. I don't know if you know Eichhornia crassipes, that is the water hyacinth. It's pest number 1 in rivers for navigation and because of its vegetative. And it doesn't stand salt. You put salt in water, it's dead. And this is a coastal lagoon. We are less than a kilometer away from the river mouth. This is a coastal lagoon, and you see Eichhornia crassipes thriving luxuriously. Conclusion, it's fresh water, it's not salt. So you have this whole transition in freshwater management that converted actually these seawater lagoons into freshwater bodies with all the consequences for the mangrove. And the problem is a loss of functionality. And then you can ask yourself, yeah, maybe there's new uses, new functions. Yes, this Sonoracea caseolaris has exploded, plus 3,000%. Is very good for the drinking production industry, the local NGOs. But the real question is, do these new functions outbalance the functions that have been lost, like fuel wood, timber wood, and so forth and so forth? And unfortunately, we have had a natural experiment, which is the tsunami disaster in 2004, where we could very well see that the lagoons that were in good state, they protected the coast much better than the lagoons that were in bad state. And of course, if you have your mangrove removed to put a tourist resort or aquaculture farm, there is no natural dike anymore. Which brings me to respecting the adaptive cycle. The adaptive cycle is now coming back to the social ecological system. It is a cycle through which every system is going. And it has what we call a conservation phase, a release phase, a reorganization phase, and an exploitation phase. And typically what happens, for example, in a release phase, it's a disturbance. It lasts hours to days. For example, you can get a canopy fire and the trees die and the productivity decreases, you have runoff, you have erosion. from the social side, you have public faith in fire management, which is affected. So you find this release. You can give examples from both the ecological and the social part. Then you have a renewal, in which you have new policies, for example. You have seedling establishment. You have a growth in which all the different links that I talked about when introducing the social ecological system are needed to make the system work. They're put into place. And then finally, we have a situation in which it's called the conservation state. It's nothing to do with biological conservation. It's just a state in this adaptive cycle. And it means everything is very rigid. Now the system is working very well, but it is rigid. And because it is rigid, it also means that it's kind of easy to break down again. And that's why very often you have this this loop, because after some time something happens again, up, release, reorganization, exploitation, conservation, release. So this system is also always going through the same loop. You have the same thing if you look for an NGO. The growth of an NGO, the establishment of an NGO, the reorganization of an NGO follows exactly the same adaptive cycle. But it's also nice to see that you have these social parts and these ecological parts that are interpreted according to the same theory. So, and some examples also, like if you look at the conservation phase and the fact that social ecological systems are most vulnerable in that phase is because people are also affecting and changing these disturbance regimes I referred to in the beginning. For example, if you always try to avoid flooding of a river, and I'm referring, for example, to the Mississippi River in the United States, if you're always trying to avoid flooding, and by damming, by locking, by sluicing the river, eventually nature is stronger than man, and so eventually the river will flood. But in the meantime, you have so many hundreds of thousands of people that have been living in an area where you're not supposed to live and where they're not used to have flooding. And that's, of course, leading to a catastrophe. In nature, there is no catastrophes. It's just nature, this inundation. The catastrophe is a social word because it affects the investments, the economics, the lives of people that are living in that area. That's what makes it a catastrophe. But the inundation as such is not a catastrophe, it's nature. So, I already said this. See? Sorry. I'm going to go straight to the end now. Yes. And this is also work we're still talking about or researching, because now, in order to protect the coast, you can use mangroves, but mangroves are also not universal. So in this case, in Sri Lanka, for example, we saw that the coast is more than 90% vulnerable, but only for less than 1/3%, mangroves can actually protect the coast. So in 2/3 of the coastline, you have to find other ways of protecting the coast. And we looked at different groups of plants that were affected or not affected by the tsunami in 2004, and even plantations of coconut or casuarina could help protecting the coast. I don't say it doesn't have side effects, because casuarina, for example, is very bad for turtles, because you have the roots are going everywhere, and turtles get a very hard time digging in the sand. But at least for coastal protection, for breaking the energy of a tsunami wave or of a hurricane wave, it can help. So that brings me to the very last slide, which is actually one about this application of this adaptive cycle to the mangrove. So my concept, and I'm just going to stick with this upper figure, this is actually what we, how can I explain it? The graph shows you basically the state of a forest on the x-axis and the pressure on the on the y-axis, and the pressure, any anthropogenic pressure on the x-axis. And as you increase your pressure, where's my mouse? My mouse doesn't want to, there it is. As you increase the pressure, your state of your ecosystem is going slowly down until suddenly it drops to another level. But then to go back to the original level, it's not enough to decrease the pressure a little bit, because you have to follow another pathway in order to get back to this level. It's called hysteresis. So it is the fact that in, let's call it a graph, in a graph, the pathway to go from point A to point B is a different one than to go from point B back to point A. And what we have in between these 2 points, this dashed line, it is an unstable state. So how I can show it better, it is by this topology with 2 depressions. And you have a little ball that is rolling and trying to go to the bottom of a depression. So one depression is one state, and another depression is another state. And the pressure is actually the force that you exert on that ball. So if you push it, at a certain moment it's going to roll over the hill and into the other depression. Then you have another alternative stable state. And it is a concept that was invented or discovered in turbid and clear lakes in the Netherlands by Martin Scheffer et al. But by looking at this cryptic ecological degradation theory that we have been developing, I was thinking that maybe, I've not proven it, this is purely conceptual, I believe that the functionality of the mangrove is also going down more and more with the expansion of mangrove associate species and less important mangrove species. So with this slide, thinking about functionality of the mangrove, that we really have to think much more about how the mangrove functions, goods and services are with respect to the biodiversity in mangrove is very important towards